All right, so I skipped question 12 because it's a pretty basic binomial. So in 12, in A, you're just checking bins, and then in B, you're just finding a probability. And when you get that probability, deciding if you believe the claim is going to be based on if that's a very small probability or a not so small probability. So I'm going to let you do that one on your own. But here's number 13. Ed and Adelaide attend the same high school but are in different math classes. The time it takes Ed to do his math homework is normal, with a mean of 25 minutes and a standard deviation of 5 minutes. I'm going to start underlining some stuff. So for Ed, it's normal. That's important. The mean's 25, and standard deviation's 5. And then Adelaide, the time it takes her to do her math homework is also normal. And that has a mean of 50 and a standard deviation of 10. So when you see the word normal, that's when you're thinking about those pictures we draw. Let's see what we're asked to find. Randomly select one math assignment of Ed's and one math assignment of Adelaide's. Let the random variable D be the difference of A minus E. Find the mean and standard deviation of D. So in part A, I'm finding this new random variable D, probably stands for difference. And that's A minus E, or Adelaide minus Ed. So to find the mean, I did a couple of videos on these already. To find the mean, mu, all right, I paused it to type this just so I save a little time for you. So the mu of D is going to be the differences of Adelaide and Ed's means. So meaning mu A, and we saw that was 50 minutes. So Adelaide's mean was 50 minus Ed's was 25. And that difference, you get 25 minutes. So the mean difference for the difference is 25. The standard deviation of, all right, and the formula for standard deviation, if you remember back, I made a couple of videos about this as well. Whether you take the sum or the difference of two variables, to find their new standard deviation, you take the square root of the sum of the variances, meaning you add Adelaide's variance to Ed's variance, and then take the square root. So if you do that here, we're going to take the square root. Adelaide's standard deviation was 10, so 10 squared gives me 100, plus Ed's was 5. 5 squared is 25. And if I take the square root of that, it gives us 11.18 minutes. So there's the mean and standard deviation for part A. And then part B, find the probability Ed spent longer on his homework than Adelaide did on hers. So let's think about what that means. If Ed took longer than Adelaide, meaning his homework time was greater than Adelaide's, and I want to do less work, so I already have A minus E. So if you think about algebra, and I just go ahead and I subtract this E from both sides, so minus E, and from the A minus E, I end up getting that distribution we just worked with. But on the left side, E minus E is 0. So I'm going to want to solve 0 greater than A minus E. Or flip that around. That's the same thing as saying I'm going to find the probability that A minus E is less than 0. And I can further rewrite that using what we found in part A, the probability of D. That's the difference. That's what we called A minus E in part A is less than 0. And let's think about that. So if you remember, and I think it was 6-2 with these combinations of random variables, the shape remains unchanged. So since the shape was normal to begin with, the shape will still be normal. So now I'm going to have a normal curve. To find this probability, I have this normal curve. Much harder to write with my finger. The mean of this normal curve is the mean we found in part A, so 25. And if I want to know the probability that that is less than 0, 0 is somewhere over here. And less means shade to the left. Wow, it's great shading. And I'm going to calculate that just using a norm CDF. So I'm going to do norm CDF. My lower bound's negative George Sink. My upper bound's 0. The mean was 25. Move this over here. The mean was 25 and our standard deviation was 11.18, I think. And if you do that in the calculator, you end up getting 0.013. And I want to talk about that probability a little bit. So that 0.013, I mentioned in the second part of 12, you're going to be asked, is the claim true? What's unusual? So here, 0.01, that means only 1% of the time it's going to take Ed longer than Adelaide to do his homework. So that's not very likely. So if we were taking some random homework assignment, I would say that assignment would be relatively difficult if it took Ed longer than Adelaide. So 0.013 is a very small and unlikely probability. So it's usually cause for a little suspect. All right, that's it for question 13. Good luck.